Thank you so much for joining this channel. So we are in day 14 now. So day 14 is very important for a software developer. The reason is like for any developer, when developers start working on any development project or enhancement project or maintenance project, it's very important that we look into the non-functional areas like security, authentication, logging, all those things, right? So when I say observability and telemetry, it is very important part of the any development project or any initiative. Without this, it's very difficult actually to manage the post-production issues or any environment, and also maintaining the defects, coordination with the QA and the product owner or developer or business analyst. So it's very important that to find the root cause quickly. And you know that when you start working on this day series, we started with the code understanding agent. The reason is the developer should understand what is the code, what is the use of the code, how we can do the peer review, how we can improve the peer review process through the agentic AI. So until unless we capture the exceptions, logging details, information, it's very difficult to actually track down where is the issue. So the day 14 specifically focuses on observability and telemetry for AI agents. We already aware that if we do any non-cloud based project, we can use database as a log, text file, XML file, Windows diagnostics you can use, right, for logging purpose. When it comes to the Azure, you can go with the Azure application app insight, Azure Monitor, Log Analytics. So those things are very important actually to capture information, creating alerts, tickets, and everything. All are connected to each other. So as usual, we are going with the engineering AI series, .NET and semantic kernel with Olama, monitoring prompts. So here, since we are in the AI world, we are working with the prompts, responses, and agent performance. It's very important to understand what prompt we are sending, right? How LLM is performing. Earlier, what we are doing when you were writing any method and everything, we are putting entry criteria, exit criteria. If any exception comes, we are logging that. We are using global exception handling. Similarly, we are actually trying to put some sort of telemetry so that we can go with the KPIs when you actually try to start fixing the defects and other things, right? So its purpose is monitoring prompts, responses, and the agent performance. We will do detailing of the agent performance in the upcoming days. So why observability matters? AI agents are hard to debug, right? You cannot debug. You are talking to the semantic kernel talk to the Olama or the LLM, right? Within the LLM, you cannot debug anything. So what prompt you are sending, what are the input you are sending, that is very important to capture in terms of further troubleshooting or understand the behavior of the application. So observability helps track prompts, responses, latency, and the failures. Why we monitor in AI agents? Because the prompt input, LLM response, execution time, error, failures. See, you cannot go with always happy path, right? The prompt may work wrongly. Even if you give a right prompt, the LLM is responding abruptly, or there is no response from the LLM also. Something is down. Anything can happen, right? So we need to capture all the information just like we do in the traditional software development. So what is the architectural overview? It is user request, the same thing, agent, telemetry layer. We are getting a telemetry layer which will capture the information either in the log file or in the agent. We will show that in the demo. And the element tools will be called metrics and logs. So the telemetry model is agent execution log, agent name, prompt, response. These things are the parameters we will capture, timestamp, execution time, and everything. So logging prompts and responses, capture prompts and LLM responses, store logs for debugging and auditing. Metrics collection, metric execution latency, track performance, monitor users pattern. So the output will be look like agent name, prompt, response, execution time, all these things will come, and that will be stored into the agent underscore log.json. We are not using any cloud or other facility like their database. We will save it as a JSON file. So what is the benefit of the observability? Debugging an AI agent, track the performance, improve the reliability and enterprise ready AI system. AI observability concept, prompt logging, response tracking, execution latency, agent monitoring AI. So this is essentially for real world AI system. Otherwise, you cannot achieve the accuracy or the correction when it comes to the production. And if something goes wrong, it's very difficult to track down where is the issue. So we'll go in the day 15 performance, but that is the day 15 purpose, and hope this is okay. And we'll go with the PDF and the efficiency in terms of multiple factor like debug, tracking, and everything for the AI agent. So in engineering AI agent, we already have the playlist, and we are using .NET 8, semantic kernel, Olama, telemetry models, and logging and matrices that we already discussed. Let's go the technical details. So just really recap. If you start from the day 9, it will be easier to understand the day 13, and in day 14, we are doing this logging and monitoring. So problem with observability load, AI agent operator as a black box, right? You are using LLM, you are using semantic kernel, you don't know exactly what they are doing internally when you are giving the prompt. We are expecting that the LLM will come up with the actual or accurate response. You know that the response of LLM depend on two factors: that how you are giving the prompt, whether the prompt is right or wrong, and how LLM is efficient or trained, right? So based on the training of the LLM also important. So typically issues are prompt failure, unexpected responses, slow model. Sometimes the model will be slow and get timeout. Tool failure. Tool failure means we already discussed in the day 9, day 11, 13, 11, 12. We are using external tools, right? The tool also may, because when tool don't bring the data. so the LLM will face issues, right? Because LLM also need the input from the tools so that it can give a proper response instead of doing any hallucination. So every tool, system prompt, LLM, all are interlinked. So the more you can resolve, do the troubleshooting, the more faster you can solve the problem and keep it to the next level. Without observability, what? You cannot debug, you cannot monitor, you cannot track. Why observability? Observability means monitoring the internal behavior of a system. In AI agents, we track prompts, LLM response, execution, error, tool uses, right? We already discussed tool what is tool uses. We already using the prompt in all the days. LLM response, how LLM is responding, that also you know. But right now the important thing is that we will count or we will track the execution time, the errors. That is very important. So what is structure output? Structure output we already discussed the day 13 that we will get it in the strict JSON format. Same thing will happen. The only difference is from the day 13 to day 14 that we are introducing the telemetry layer, right? That will actually capture all the logging and metrics details. That is important for the as a KPIs for troubleshooting. So the console output will be like code review executed for this second and log file will be. So log file will be created and the agent name, time, timestamp, all we will get it. Why it is critical? We already discussed. We are just repeating one more again so that you these things injected in your mind. The debugging prompts, monitor latency, identifying slow agents, tracking failures, improve reliability. These are all very important, right? Because prompt also may go wrong. You're monitoring latency. You don't know okay how where this your cloud and everything is deployed. It will take time. Slow agents, tracking failures. So without latency, without telemetry, AI system cannot scale in production. So enterprise observability stack in real system telemetry is sent to the application insight. Application insight is a part of the Azure cloud. I think if you search into the chat GPT also you will understand what is Prometheus, Grafana, Azure Monitor, Open Telemetry. These are very common terms. Okay, whoever is working with the cloud-based application. So when you are generating the telemetry, right, that will be available in App Insight, Prometheus, Grafana, Azure Monitor, Open Telemetry, Splunk, Log Analytics. So yes, we have started with the basic logging, but architecture supports enterprise tool also that can be done in the higher version. Local and cloud you already discussed. There is nothing new about that. To those who already done the day 1 to day 12, they know that. Benefit debug prompt, monitor LLM performance, track agent behavior, defect failure early. Because the more we detect the failures early, the more the system will be stable, right? Enable production AI system. Observability transform AI agent into enterprise ready software system. The series progress, I think we already discussed in the PPT also. The day 12, how we are doing, and we'll do in the day 15 to day 18. That is the plan. That will be more interesting. So key takeaways is that we have to debug the prompt, or you can say we have to record the prompt. We have to record the LLM response. We have to check the execution time, how much time it is taking for execution, and also the failure we have to. If we capture these 4 KPIs, prompt details, responses, execution, and failure, it's very easy for AI engineers to monitor, debug, and optimize the intelligence system. So project architecture now. So project architecture day 14 is we are using the code review agent. This agent is nothing but we will talk to the Olama using the semantic kernel. Middleware we have introduced, which will take care of this telemetry part. What will be the telemetry part? Which will talk to the observability like telemetry logger, metrics logger, agent execution logger, right? Because we are checking the prompt, we are checking the execution time, we are checking what? We are checking uh, LLM response, right? And failures. And the response, the code review result, it is same as the day 13 strict JSON format. This is the file on which this agent will work upon. And program.cc is the entry point. Execution flow is same like the previous days. Only difference is the telemetry middleware was introduced. The middleware will lab or the agent execution. So let's go to the demo. Came to the demo part. So we already discussed the architecture that we have a agent. This is a code review agent. Code review agent nothing but which actually connect to the Olama through semantic kernel, and we are providing a system prompt. System prompt. So the this architecture is similar to the day 13. Only difference is we have introduced the telemetry middleware. Telemetry middleware will connect to the telemetry logger and the metrics collector. So this telemetry logger and metrics collector is nothing but this one. What we are doing actually. So in the telemetry logger, we are creating a file. Inside the file, we will store the data details like logging details. We will show that metrics logger, how much time it will taking. Agent execution log. This is the details we already discussed, right? We have prompt, response, execution time, timestamp. These are the things we will capture. So how the flow will be? So this is the code on which these things will be applied. So let's see. Now we can see that we already connecting the Olama. Let's see how it is working. So this is the file. This is the JSON file which will be used for capturing the log details, initializing the telemetry. Now initializing the kernel. The code review agent is ready. Now we will call the review. In the review part, the same thing. We are having this prompt. This prompt we already used as a JSON prompt. The code already we captured on which you are doing. This is the code on which we are applying this agentic AI. Now let's go inside. So we already introduced the telemetry middleware. So we have to capture the execution's time using the stopwatch, right? So we have introduced the stopwatch. The stopwatch will start and then it will execute actually the method, the code review agent. It will call the semantic kernel, which will connect to the LLM. So only difference is the telemetry we are introducing before calling the LLM through the code review agent, right? Where we started the stopwatch. JSON we got. This is the result. So the stopwatch we are stopping because the execution has been completed. Now the agent name we know, code review agent. The prompt we know, what prompt we are giving. The response also we know, what response we are getting. This is a strict JSON format that you already discussed in the day 13. Also, we are capturing the execution time in millisecond. This is the time second actually being used to collect the information. And today's date, we are recording on the 7th March 2026. Now we are doing the log. The log we already discussed, right? That we have a file we have created. This is the log JSON file. Log details. Then the metrics record, agent name with the metrics record. The response. The response is that the strict JSON. But along with that, so the response is similar to the what is in day 13, right? We are returning the strict JSON response. But the additional part is that we are doing the logs of the time and everything that we will show how that file has been created. Code review result, the same thing, recommendation. And then we are printing. So you can see the code review agent executed in this millisecond that we are printing. This is the data we are capturing. Now we will see the file which is being created as a log file. See the agent underscore JSON has been created. See the code review agent been executed. What is the prompt? So now the latest execution is what time? There are multiple entries actually being made. So that you can see that the timestamp is 7th March, 7th March, 7 months. It is 8:45. Yeah, so this is the last one. So you can see that the prompt we have captured, agent name we have captured. Total execution time is this one. This is our last one. This I executed while preparing the demo. This is the execution while making this video. So you can see that the timing has been the same. It is same time 10. 1109160.732, and so you can add more parameter based on your requirement, and this data now it is getting generated into the log file. It can be stored in the database, it can be stored into the app inside Grafana, wherever you want, but ultimately you will get to know, okay, what prompt has been given, what if something goes wrong. I haven't done the experiment, but yes, so we can do in the later stage. If exception come, how it will give. So definitely exception comes, then the exception details will be captured, and I will enhance that in the further days with the timestamp and everything. Thank you. I will again visit in the next day.